papers there in front of you, and you need the chart that's there as well. Okay, in your calculator, I want you to click the Stat button, and the Edit tab is what comes up.
Fearless.
All right, so you're going to click your Stat button. And edit. So hit enter. And into L1, okay, yours should be blank. If they're not blank, then just clear out the numbers that are there. But into L1, I want you to list all of your X values. And then into L2, list your Y values.
Are we going all the way up to 70?
No, you're going to stop at the 65, the ones that are on that chart there. So yeah, the 65. All right, now we're going to talk about creating a either line of best fit or a curve of best fit for these. And so we're going to type in and do linear regressions and then quadratic regressions. Now, your R-squared value is how accurate your line of best fit is. So if we look at something like this, if we look at a set of data, you know, like this, okay, and we have a line of best fit, and we say that we draw our line there, your R-squared value is going to be really low, okay, because all of these are pretty far away from this line, all right? Your R-squared value, if you were to draw a line straight through those, and it's going to intersect all four of those points, your R-squared value is going to be very close to 1, if not exactly 1, because those are right on that line. Okay, so the closer your R-squared value is, then the more efficient your graph is, or your line of best fit. So your calculator finds your R-squared values for you. It's nothing that you have to calculate on your own. All right, so if we follow these directions here, go back to your stat. So these values are now stored in your calculator. If you go back to your stat button, and then arrow over to the calc function, option 4 is a linear regression. Now, a linear regression is going to form what kind of curve or line? Okay, good. It's going to be a line. So, linear regression, option 4. Now, yours might automatically, these older calculators might automatically say linear regression. I'm going to have to enter a couple of times. If yours looks like mine, you do. Hit enter on calculate. And this is what comes up. So y equals ax plus b. And you might have to hit enter on yours once to get it all to come up. Yeah, once it says linear regression, ax plus b, hit enter. Yep, there you go. And your screen should look like this. Okay, now look at this R-squared value, 0.76. And you might think, well, that's not really that far from 1. But actually, it is pretty significantly far from 1. All right, so looking at this equation, what's our slope in this problem? What's your slope? What value represents your slope? Ax plus b. M would be your value that's associated with x, and in this case it's a. So 0.34 would be our slope, and what would our y-intercept be? That would be your b value. Okay, your y-intercept would be your b value. Okay, so linear regression. Let's see if we can get something that's actually closer to 1, our R-squared value. And if you think about your set of data...
Good afternoon. This is a reminder to all students.
All right, we're going to look at your linear regression at this point, okay? So once you've gone in and entered your data, okay, we're going to go to the stat function. So hit stat on your calculator, and then arrow over to option 4, and you're going to look at linear regression, okay? So at this point, you're going to hit stat, arrow over to calc. Linear regression is option 4. Now, and you'll wanna hit enter. Your screen probably does not look like that. But once you hit enter, okay, and what we really care about at this point is your R squared value. And your R squared value needs to be as close to 1 as possible, okay? Which means that it's a, estimating very closely. If you've got lines like this, that's gonna be an R squared value of 1, or very close to 1, because it's going straight through there. And that's how close your prediction actually is gonna be. All right, so on your sheet of paper, go ahead and record this R squared value at this point, 0.76. And again, it might seem close to 1, but really 0.76 is pretty far away from 1, if you think about it. And we're gonna look at something else in just a second, to show you really how far that is. So go ahead and record that value. And then let's go back for just a moment and look at our set of data. Where's our data here? Here we go. Here it is. Okay, so if you're looking at this data, think about your miles per gallon. What's happening here? You're increasing to this point, and then what happens? Then you start decreasing, okay? So you're increasing, and then you start decreasing. So if you think about a graph and what that looks like, you're increasing, and then you start to decrease. So that's not really a line. What's that showing more? What's it looking more like? A parabola, okay? So that's going to be more of a quadratic function, okay? So that's going to be a quadratic. So that's actually the regression model that we're going to look at next. So go back and now to the stat. Arrow over to calc. And we're going to look at our quadratic regression now, 0.5, or option 5. Again, hit enter until your screen looks like this. Now, what do you notice about your R squared value this time? It's much closer to 1, okay? So now that we're closer to 1, this is going to fit our data much closer, okay? So at this point, what I want you to do on your sheet of paper there is record your R squared value, and then also record your A, B, and C value. And notice your A, B, and C value here are going to fill in to your standard form of a quadratic equation. Okay, so record those values. And you don't have to record all those decimals. I would go at least 3 decimal places out instead of doing all those. But if you, whatever you've already done is fine, since I just told you that. But at least 3 decimal places out. Okay, so once you have that done, I want you to go to your y equals on your calculator. Now we're going to set this up so we can see our data, number 1, and so we can see our line. But we're first going to look at our data. Okay, so the first thing that you want to do is you want to turn your plot 1 on. So if you arrow up, once you hit y equals and you arrow up, hit enter on plot 1. So you're going to turn that on. Okay, and when you arrow back down, you'll see that it's highlighted. Don't enter anything yet until y1. All right, now if you look at your paper that I gave you here, analyzing your graph, this is what we're going to look at. I show you how to set up your window, your table of value, to show your table of values. So if you'll go to window and then enter that information in there. So your X minimum is going to be 0, maximum 80. Okay, so it's listed on there for you. But you got to think about what we're doing here. Your X values are your miles per hour. So we're going to look at our X values from 0 to 80 miles per hour. Okay, and then your Y values represent your miles per gallon. And the highest miles per gallon that we got was about 35, 36. And so you don't really need to go past 40. So we're narrowing and zooming in our function at that point, or a graph at that point. And once you have that, view your graph. And those are your ordered pairs, okay, from that chart. Now, it's not a perfect parabola, a perfect x squared function, okay, but you can see that you're increasing and then that data starts to drop off, okay, so you can see that you're increasing and it starts to drop off. All right. Let's see where we are. it wants you to estimate. Remember, we estimated what we thought our 75 miles per hour was going to be, what our miles per gallon would be at that point. So now let's look and see what our function is actually going to be doing, okay, at that point. So what we actually want to do, we want to go first to type in our equation to y1. So go back to y1 and type in your equation. Okay, so you've got your a for your x squared coefficient, you've got b for your x coefficient, and then c. Alright, so we're going to see how close or how good our actual estimate was by looking at this. And how well our curve is going to fit that set of data. Alright, so you're entering that into y1. Yeah. Oh dear, we moved that up there. Alright, after you have that put up there, go ahead and look at your graph again, and now it's going to plot that actual curve, okay? It's going to plot your curve to see what it's going to look like. And notice, it's a pretty close fit. Our x squared value was 0.9, what was it, 0.96? Okay, so your r squared value, was 0.96, so it's pretty close to 1. You've got a few points that are kind of far away, but it's not that bad. It fits it pretty well. Okay, so let's see what our curve of best fit, or our fitted curve here, is going to estimate for our value at 75. So if you hit second trace, or your calc function, let's determine what the value is. So hit enter at 1 at 75. So you're going to enter 75 here and see what it turns out. Okay? And if you remember back to our estimates, most of us guessed around 30, 30.5. I think one person did guess 28. And so that's what the estimate is at this point. This is guessing or giving us 28 as our miles per gallon. All right. And so that's the answer to number 4 there on your calculator. I mean on your sheet. Okay, so we can see our gas mileage is not so great down here at 0, closer to 0. As we're, gaining speed, our gas mileage is getting a little bit better, and then it comes to a peak where it maxes out up here. And then as you speed up, then your gas mileage is going back down again. Okay, it's decreasing. So what we've really discussed is how we can save money on gas. And how you can save money on gas is not going that 75 miles per hour all the time, because that's getting 28 miles to a gallon. Whereas if you're going 55 miles per hour, you are actually getting a much higher rate, okay, or speed for your gas mileage. So you're getting about 35 miles to the gallon. Okay, so let's look now at a couple of questions. This morning, the gas was $2.91 at the Circle K up here on Martintown Road. Okay, so based on this information and what we previously discussed, I want you to calculate the money that you would save, okay, by driving at 55 miles per gallon rather than 75 miles per gallon. Okay, so I want you to spend just a moment calculating that out. Okay, and then after that, I want you to see what that's going to save you over the course of a year. Okay, if you drive approximately, which this is true, you normally drive between 10,000, probably more like 12,000 miles to 15 or 20,000 miles. So we'll say we've driven 15,000 miles in a year, that's approximately. So we're going to see what it costs to save us at that point. Okay. So those are the two things we're going to calculate.